Hi everybody, welcome to another one of my videos. Today I'm going to be looking at part 2 of my demand and supply series. This is also part of my economics basics series as well. So what I covered in part 1 was I looked at the market as a whole, in terms of what the market for a particular good, like that was bananas, and that was the whole market for bananas. So not looking at individual sellers or looking at individuals, just looking very, very broadly at the market. Today I'm going to be looking at it from the individual's perspective. So what we look at in terms of our own demand. And so we're going to be looking a little bit more at things like diminishing marginal utility. So the more you consume of something, the less value it has to you as well. And I'm also going to be looking at how we use our budgets to determine how much of something that we should obtain or buy, and how that measures with our utility, and also how we can look at not just one good but maybe two goods as well. But generally though, we're going to be still looking, like I mentioned before, from a partial equilibrium perspective. So it's not going to be looking at the broader economy, it's just going to be looking at just one or two goods from an individual's perspective. So generally equilibrium will be something that we're looking at a lot later on, wouldn't be part of this series because it's actually quite complicated and quite sophisticated. So we're going to keep it fairly simple with simple demand and supply curves for now. So we're going to start off with the individual's demand curve. So your demand curve, it could be a straight line, it could be linear, like I showed you in the first video, or you could have a concave demand curve. Again, that's fairly common, that's very common as well in terms of you're looking at the market as a whole. We could have a convex curve, sorry, did I say convex? Yes, a convex demand curve. So that's what we got here, and typically you don't see too many of them, but I think in this example here it probably fits quite nicely. And why you could potentially have a convex demand curve is that you're starting to lose utility for something, like in the case of bananas, after you've consumed a few. Like for example, you may get quite high utility on your first, but after that, after you start to lose your appetite, and eventually you don't want any more because it's going to make you sick. So that's something very typical for food, and you could get that sort of demand curve. Later on we're going to be looking at concave demand curves. So I can explain the demand here in this table. So for the first banana, for example, you may be willing to pay $15. The second banana may only be willing to pay $12. The third banana may be $7. And then that last banana you wouldn't be willing to pay anything because you no longer have any utility from that banana because you're full. You eat any more, you're going to be sick. And if you consume your fifth banana, in fact, you probably want money. You want to be paying money to eat it because it's actually causing you discomfort. So in this case, I've got a very simple little demand function here. So that's demand equals to 16. So that would be your y-intercept. So that is what I showed you just now, where the demand curve intersects with your y-axis. And I've got a square minus x squared. So for every banana you eat, your demand falls by that in proportion, whatever. So that's been used to actually calculate how much a person's willing to pay at those various levels of quantity. So, okay. So we've got a demand function, we've also got to still consider supply. Even though individuals, because you're just one person, you can't actually influence supply. But supply still plays a role because that determines how much you actually buy of something. So as we got here, so I've used a flat supply curve, and where that supply curve meets the demand curve, that will give you your equilibrium price, and that's basically the price that's being set by the supermarket, so you don't influence that. But that also gives you equilibrium quantity, which you can influence, and that's how many of a particular thing you're buying, like how many bananas are you buying. So you get to that point. Alright, another thing I want to talk about is consumer surplus. I mentioned that in the previous video, but now we're looking at it from one person's perspective. So the green area, the area above the supply curve and underneath the demand curve, that is your consumer surplus, and that goes up until the point of equilibrium. Beyond that, you don't buy anymore, and in fact you have a negative, you would call it a negative consumer surplus, but assume that doesn't happen because we'd assume people don't continue to buy something when they don't need it. In reality, I think that can happen because everybody's not always aware of their willingness to pay. So your consumer surplus is your difference between what you're willing to pay and how much you actually pay. So you have more consumer surplus early on for those first few bananas that you're buying, and it's considerably higher because you've got a much higher value. And as the more and more you consume, then you get less consumer surplus until you value it the same as what they're being sold for, and then it drops below that, and that's where you reach your equilibrium, and you wouldn't buy anymore because that consumer surplus, in effect, if that's your extra utility you're getting over compared to not buying the bananas or for you to get something else. What I'm going to look at now is if we have two goods, and this is going to something that I think is covered off in most university courses. That'd be looking at things like your indifference curves, we'll talk about in a minute, and also your budget. And this is comparing utility of two goods and assuming that this is just a world where there are only two things you can buy. Bear that in mind. So that's why we can do it. This is quite unrealistic, but it's an interesting way of showing diminishing margin utility and how we don't just buy all of one thing, but we actually need to buy a number of other things as well. In this case, it'd be a combination of bananas and pineapples. So my very first video as a series, I covered off on utility and choice. So you might want to actually go back and look at that video again after this, just a bit of a recap. But utility is basically it's your satisfaction that you obtain from something. And I've already talked about utility in here before, and consumer surplus and increasing your utility by consuming things that you have a higher willingness to pay over what the price is. So utility in this case, when you're going to be looking at two goods, plays an important part in terms of what you select. Alright, before we jump to the indifference curves, before I explain that, there's several ways of measuring utility. One approach is cardinal utility, and that's assigning a value to your utility. And we often use in economics something known as utils. But utils isn't something that's universal. Not everybody has the same util value. Like for example, we've got here mangoes as the highest utility of 14 utils. But what does that mean to someone else? They could have the same value for mangoes, but they might rate it as 28 utils, 45 utils. You don't trade in utils, you trade in dollars. So another approach is to actually just rank, and that's what we call an ordinal approach. So for example, you got mangoes and they rank number 1 because they give you the most utility. Then you may have oranges number 2, apples 3, melons 4, and potatoes 5. So that's just in the ranking, and that tells you how you prefer, what is your order of preference for these particular goods. But it doesn't actually tell you the extent of that difference. So another approach, and this is not talked about too much, I don't think, university and courses and stuff like that, and that's your relative utility, and that is measuring utility in respect to something. So it's not an absolute value. So what I measured here is utility in respect to potatoes. So what was your potatoes? That gave you 2 utils, for example. So mangoes was 14. So relatively, the ratio would be 7:1. Like for melons, for example, that was 6 utils and 2 utils for potatoes. So that gives you a ratio of 3:1. This is a little bit more useful when you're comparing between people. Like I mentioned before, 14 utils to someone else could be 38 utils, and that could be, 6 could be 12 utils or something along those lines. It's all a little bit different, but if you look at it in terms of the ratios, that gives you something a little bit more you can compare on. I always found it a little bit more useful than actually just purely looking at numbers that vary. It's completely different from individuals. You can't make comparisons. And ordinal as well. Ordinal doesn't give you extended difference. Like you could have a number 1 that's way ahead of all the rest. You could have a number 1, 2, 3, 4, and 5 all very, very close. You wouldn't be able to establish that by just having an order. That's why I personally like the use of a relative utility rather than ordering or absolutes. But anyway, that is, if you want to know more, I actually got my master's thesis that actually uses a relative utility approach. So you can actually, I'll have the link in the description of this video if you want to read more about that. Alright, so let's now take a look at indifference curves. So what is an indifference curve? Indifference curve is a curve that actually has the same, you can see that it has the same level of utility. So in this case, we've got bananas and pineapples. So any combination of bananas and pineapples that fall on that curve produces the same utility. So for example, we've got IC1. So let's say that gives you a utility of 12 utils, for example. So every combination on that gives you 12 utils. So for example, B3 of bananas and P3 of pineapples, those quantities give you that level of utility. Or it could be B1 and P1. Again, it would give you that same level of utility. So it's all the various combinations of bananas and pineapples that give you that same level of utility. So in a sense, we've got an almost infinite number of indifference curves within a plane. So here I've just used 2, and that's actually to make a point in terms of how you maximize utility. So IC2 actually gives you a higher utility for the combination of pineapples and bananas. So ideally you'd rather be on IC2 than you would on IC1 because that gives you higher utility. But you can't just go to IC2, you've got to budget and you've got to decide what combination of bananas and pineapples you're going to get in order to maximize that. So you need your budget to actually be on a tangent to your indifference curve. So it should be intersecting on that tangent and not passing through. So as we got here, we got B2 of bananas and P2 of pineapples. So that combination is within your budget, it falls exactly on your budget constraint, and it also gets you on your highest level of utility because that gets you on the higher indifference curve. With the same budget you could get B1 and P1 and also B3 and P3. And all of those you could get using in your entire budget, but that gives you a much lower level utility. Well, it's a lower level, it's on a lower indifference curve. So if you want to maximize your utility, you would then go with B2 and P2. I've also got an equation here, and if you remember from my utility and choice video earlier on, my very first video, this is what we call a Cobb-Douglas function. So utility equals bananas to the power of half multiplied by pineapples to the power of half. So what that tells you is that generally you need to have a combination of the two to maximize your utility. If either of those was 0, for example, that would give you 0 utility. And because they're giving you the same, roughly the same level of utility, you'd ideally want to have a very similar number, assuming that they cost a similar amount. And that's, again, that's where your budget comes into place. So your budget is the price of your bananas multiplied by the quantity plus the price of your pineapples multiplied by your quantity. So that has quite an effect as well on what combination you picked. And I'm going to show you in a minute how that changes the quantity of bananas and pineapples if there's a shift in that budget function. Okay, here we are now. So now we've assumed that your price of pineapples has gone up. As you can see, there's an inward shift of your budget. So in effect, that you've got a maximum number of pineapples, so where they intersect on your x-axis, is considerably lower than it was previously. So that forces you now to actually change your composition of how many you buy. And because of the nature of the utility function, you still buy the same number of bananas, but actually now buy less pineapple because they've gone up in price. That's what we're going to talk about next, is the substitution effect and the income effect of when you have a price change. So when you have a price change, what happens is that in effect it affects your income in terms of your purchasing power. So if you have an increase in the cost of pineapples, your purchasing power has actually gone down. So that has an income effect in the sense that you can buy less things. Now you may be earning the same amount of money, but you can buy less with that. So you look at that as sort of like in terms of inflation, for example. If you've got inflation in the economy, your real income falls because you've got a drop in purchasing power. So that's the same here. It's also the same the other way around. If the price of pineapples fell, you'd experience an increase in income in terms of real income, in terms of purchasing power. So let's look at it in terms of the income effect and a substitution effect. So we've got that shift. So now if we imagine that there isn't a price change, so it's just a reduction in budget. So you've got less budget because higher prices all around. So that change in the number of pineapples and bananas, that is your income effect. So you can see you actually buy less pineapples and you also buy less bananas if you have a reduction in income. And then if we actually switch to the actual budget now, so that's tilting back to what it should be, you'll see that you're buying more bananas and you're actually buying less pineapples. So that is actually a substitution effect. You're actually moving in and you're actually getting more bananas, in the sense that bananas are relatively cheaper to pineapples because pineapples have gone up in price. So we call that the substitution effect. So therefore you've got a net effect for pineapples. You go from P2 to the purple P2, what's that, to the subscript that. And with bananas, you also had an income effect, which reduced the number of bananas you're going to buy because of that reduced income. But you end up buying the same number of bananas because your substitution effect and your income effect were the same. And that's not always the case. You could actually have a larger substitution effect, so you end up with more bananas. or you could have a less substitution effect where you actually end up with both less bananas and pineapples. And it also depends on the relationship between bananas and pineapples. So that all seems fairly complicated in terms of looking at indifference curves. It's all kind of messy. So just in short, we look at it in terms of our demand and supply. This is looking at pineapples. So what has happened here, the price of pineapples have gone up. It could be for any reason, I don't know. But let's just say supply costs. The costs have gone up because there could be a shortage of pineapples. They're harder to get, they're harder to grow. So because of that shortage, prices have gone up. You've got a reduction in supply. So therefore, that's going to reduce the quantity of pineapples bought, and it's going to be at a higher price. It's just another way of presenting it. Alright, so this is similar to what I had in part 1. We've got complements and we've got substitutes. So in the case of what we mentioned just now with pineapples and bananas, we didn't really assume any sort of substitution effect between the two. Whether they're almost kind of indifferent in the sense that demand for bananas did not change whether there was an actual reduction or an increase in the price of pineapples. But potentially that could have been different. So imagine if they are substitutes, for example. So what would have happened with the reduction in the price, the increase in the price of pineapples? Then you would have got a higher demand for bananas. So the demand for bananas would have gone up because they are the substitute. So you would have experienced a shift in demand towards bananas. And likewise, if they were complements, you would have seen a reduction in demand for bananas when there was a fall. And in this case, we kept it the same, so we didn't actually show that substitute complement effect. But again, that can get rather complicated. You probably look at some textbooks and all that. We'll go into a lot more detail on that than I'm going to show within this presentation. Anyway, that gets us to the end of part 2. Hope you enjoyed things so far. We're going to go to part 3 in the next video. Part 3 is going to be looking at it from the suppliers side of things. That's going to be looking at firms within the market themselves and how demand and supply affects them a little bit differently. For individual firms, it doesn't look like it does for the market because you've got demand for a particular firm's goods rather than demand for the market of goods in itself. So it will be a little bit difficult. A little bit different. So anyway, this takes us to the end of the video. If you liked it, remember to hit the like button. And if you want to see more videos like this, or if you want to see part 3 when that comes out, remember to hit the subscribe button. And there's also number of other videos coming out as well. It could be related to cost-benefit analysis, or even vegan economics. So just keep tuned in, and hopefully I'll catch you soon. Thank you very much.